Up to this point in chapter 7, we've only used the side lengths of triangles to do things like determine if the triangles are proportional or solve for the missing side. But section 5, we're going to define 3 new special segments in triangles that we can also include in these proportions. So the first special segment is the altitude. Think about the altitude of an airplane. That's measuring the height of the airplane from where the airplane's at in the air straight to the ground. The altitude of a triangle is kind of the same. Okay, think of it as the height of a triangle. And it's all segment that starts at a vertex. So one of the corners. Okay, and then it is always perpendicular to the opposite side. Okay, and remember, perpendicular means to create a 90-degree angle, form a right angle. Okay, so if the triangle is an acute triangle, the altitude will be inside the triangle. Okay, if the triangle is a right triangle, it can be one of the sides of a triangle. And then if it's an obtuse triangle, that altitude can be outside the triangle. Okay. And then, like I said, if two triangles are similar, all their sides proportional, but the altitude can be included in that proportion as well. Okay, so here we've got triangle ABC, similar to triangle FGH. All right, all of these corresponding sides, AB and FG, BC and GH, and then AC and FH. Okay, that is what we talked about before, but now this section we can add that the altitude AD is also proportional to altitude FJ in that same ratio that our segments are in. Okay. The second special segment we're going to talk about is the median. Okay, but think about the median of a road in the middle of the road. The median of a triangle connects a vertex to the midpoint of the opposite side. Okay, and again, just like the altitudes up above, if two triangles are similar, then the medians are proportional to the lengths of the corresponding sides as well. Okay, so in this picture, we've got triangle ABC similar to triangle WXY. And whatever ratio the side lengths are in, so AB to WX, BC to XY, and AC to WY. We can now include these medians in that proportion as well. So CB and YZ. Okay. Last but not least is the angle bisector. Okay, remember anything that is bisecting cuts that object in half. An angle bisector is the line segment that cuts an angle into two congruent angles. Okay, and as long as two triangles are similar, so here we have triangle QRS similar to triangle KLM. Okay, then that ratio that we write those side lengths in QR to KL S to LM and QS to KM. We can now include those angle bisectors. So RT to LP. Okay. So nothing's changing, we're just able to include more parts of the triangles. Okay, so a couple examples here. Example one. We've got two similar triangles. Okay, AB and FD are corresponding sides, so that can be one of my ratios in my proportion. Okay, and since I said 15 over 12, I can now include these angle bisectors in this proportion to find the missing side. Okay, so we cross multiply. 12 times x is 12x. 8 times 15 is 120. When I divide this side by 12, I get x to be 10. Okay, this example here, I am given both of my medians. Okay, I see that P is a midpoint with these hash marks there. I see that Q is a midpoint with these hash marks there. Okay, so these medians can be included when I want to set up a proportion. So 13.5 over 9 is equal to x over 3. Okay, cross multiply, I get 9x equals 40.5. And when I divide both sides by 9, my x value is 4.5. Okay, so nothing has changed. We're still setting up a proportion, cross multiplying and solving for x. Again, we're just including more parts of these triangles. Okay. The last thing we're going to talk about here, the angle bisector is special for us. There's a second proportion that we can look at when we've got an angle bisector. Okay, so this is an angle bisector of a triangle separates the opposite side into two segments that are proportional to the length of the other two sides. So in triangle JKL here, JM is our angle bisector. Okay, so the opposite side into two congruent parts. Or I'm sorry, the opposite side into two segments. That's going to be KM and ML. Okay. Alright, so those two parts are proportional to the length of the other two sides. Okay, the other two sides are going to be JK and JL. Now, since I said KM in my numerator, KM is on this side of my angle bisector, so JK needs to go on in the numerator as well. And L was on this side. Okay, so then JL goes in the denominator there. Okay, so the two parts here are proportional to the two full sides that we have. Okay. So let's go into some examples. Okay. One trick that I've learned, and I'll do this in, let's say this color. Okay. This here is one way to set up part, full side. Okay. Another way to set it up is if you treat the angle bisector like an equal sign. Okay, and then you put your fraction bars here and here. That actually sets up your proportion for you. Okay. So this way I can say x over 4 equals 13 over 6. Okay. And if we set up that proportion like, whoops, like we did up at the top, okay, we said part over part. So 6 over 4, 4 over 6, either one. Part over part is equal to the whole side over the whole side. Okay, and either way I set this up, if you notice, we're still doing 4 times 13, and we're still doing x times 6. Okay, so either way, I'm going to get 6x equals 52. Divide both sides by 6, and that's going to be 8.6 repeating, I believe. Okay, so that's your x value. Okay. Examples 2 and 3 here are a little bit trickier. Okay, so we still want to look at part and whole side and whole side. Okay. So I definitely know I want x over something and then 6 over 14. Okay. So if I know this whole side here is 18, but I've already used x, this part here that's left over is going to be 18 minus whatever x is. Okay. And so then we've got 14x equals 108 minus 6x. Okay, we add 6x to both sides. We add 6x to both sides, we get 20x equals 108. Divide both sides by 20. We get x to be 5.4. Okay. And then the last example here. So if you want to look at part, whole, you can do that. If you want to look at the angle bisector like the equal sign, throw in the fraction bars and set up your proportion that way, you can do that as well. Okay, the important thing is here, 20 is this whole side. So this part here, to get this part, we have to take the whole side minus x. Okay. So when I'm setting up my proportion, 11 over 20 minus x is one ratio, and then we've got 14 over x as my second. Okay, cross multiply, get 11x equals 280 minus 14x. Okay, add 14 to both sides. That's 25x equals 280. Divide both sides by 25, then my x value is 10. Nope. Yes. 10 point. Nope. 11. 11.2. And that's your answer.